Guys, this is a column based connection. Can you tell me whether it is a moment connection or shear connection? Similarly, this are beam column junction. Can you tell me which one is shear connection and which one is moment connection? Well, this video will answer you all this question. Welcome to my channel. If you are a civil engineer, please subscribe this channel to get videos on analysis, design and construction. To understand shear connection and moment connection, we need to learn certain basic things. Let's consider this I section. This is the wave and this is the flange. If this section is used as a beam, can you tell me which part carry the shear force and which part carry the moment? Well, if you don't know, in that case, wave carry the shear force and flange carry the bending moment. But why? This is the cross section of I section. You have learned that this is the wave part and this is the flange. You know that at any section, if the shear force is V and the total moment of inertia is I of the section, in that case you can express the shear stress at any section by this formula, that is PQ by IB. Okay, now what is B? B is the thickness of the section where you are considering the shear stress, and Q is the moment of area which is contributing your shear stress. If you draw this shear stress distribution, it look like this. It varies parabolically. Okay, from this stress distribution diagram, it is clear to you that the whole region actually carry the majority of your shear stress, and this region belongs to the wave of your I section. Okay, though in the flange section there is a certain amount of stress distribution both at the top flange and at the bottom flange, but the majority of the shear stress is distributed within this wave region. That's why the wave of your I section carry the shear force. If you want to transfer the shear force from a beam to another beam or a column, so you have to connect the wave. As you can see here, the wave is connected through a angle. Okay, so you have to connect your wave to the flange of the column or the particular location of the beam. This type of connection where your only wave is connected is known as your shear connection. Why? Because here only the shear force is transferred through this wave. Based on the connection arrangement, shear connection can be beam to beam connection or beam to column connection. This shear connector can be a plate or a angle like this. If the plate is used as this connector, in that case it is known as your shear tab. This connection can be welded or bolted. If you try to visualize the flow of force, here you can see that the shear force is coming to this beam, then from this beam to this shear tab through this bolt, and from this shear tab to the flange of this column through this weld. Well, you have understand why the wave carry the shear and what is shear connection. Now, why flanges carry the bending moment and what is moment connection? Let's say this is the moment acting on this beam, and the value of this moment is M. This is the cross section of your I section, and if you plot this bending stress throughout this cross section, it looks like this. The equation of this stress is My by I, where M is the moment in the section, I is the overall moment of inertia of this section about this neutral axis, and Y is the distance from this neutral axis to the point where you want to measure the stress. It is clear from the formula that this stress distribution is a function of Y, or the distance of the fiber from the neutral axis. That's why it is maximum at the edge and it is zero at the center. This is your compressed zone and this is your tensioned zone. You can say that this is the resultant compressive force and this is the resultant tensile force. So you can see here that this moment is nothing but producing a couple like this. If the distance between the centroid of the flanges is D, in that case we can say that the magnitude of the force is nothing but M by D, and this force, whether it is tensile or compressive, these are acting along the flanges of the I section. So you can say any moment is converted into a couple and they act along the flanges. So to carry moment, flanges is the only way. But yes, from this distribution, you can say that within this wave region, there is also some stress is distributed. So certain amount of stress is also carried by this wave. But majorly, the flange carry them. That means to transfer the moment in your beam, you have to connect the flange of the beam with the flange of your column. As you can see here in this picture, the flange of the beam is connected to the flange of this column through this welding. Similarly, the bottom flange is also connected with this column flange by this welding. Naturally, in this connection, both shear through this wave and moment through this flange is transferred from this beam to this column. That's why this connection is known as your moment connection. Based on arrangement, there are three types of moment connection that are being used nowadays. First one is the flange plate moment connection. In this case, you can see here that the tensile or compressive load from the moment is transferred to this flange plate via this bolt, and then from this flange plate to the flange of column via the welding. Second one is your end plate moment connection. Here you can see through welding the whole I section is connected to this plate, and this plate is connected to the flange of the column through this bolt. Okay, so first your tensile force from the beam is transferred to the plate, then from the plate to the bolt, and finally to the flange of the column. The third one is your direct weld moment. From the name you can assume that here no flange plate or end plate is used. Directly the flanges of the beam is welded with the flange of the column. And in all of these three cases, the shear is transferred from this wave of I section to the flanges of the column. Now, what about this connection? Well, pause the video and try to visualize the load transfer. Yes, the column wave transfers the shear to the plate through this welded connection, and also if there is any moment acting in this column, they are converted into a push and into a pull like this. As the flanges are connected to the plate through this weld, this push and pull also transfer to the plate. Now you can see here that the plate is held in place by these 4 bolts. Also observe the bolt location. They are not within the flange, but they are outside of this flange. So this is similar to end plate moment connection, isn't it? Let's check. Here you can see here, this is the column compared to this picture. This is the column. Here this is the column. It is connected to this plate through welding. Okay. Here you can see through welding it is connected to the plate. Now this plate is connected with this member through this bolt outside of the flange. So here is also the bolts are located at the outside of the flange of the column. So you can say the push and pull of the column flange are transferred to the soil through this bolt. So this is a moment connected base. Suppose the bolts were in this region or in between the flanges. In that case, the push-pull of the column could not transfer to the soil through this bolt, and this base connection was at that time would be called as shear connected base. That's all. If you enjoyed this video, please don't forget to subscribe.